Today, I'm talking about divergence theorem. Divergence is expressed by dot product between electric flux density and this symbol. This symbol must be vector, and this symbol is called del or nabla. So, in other words, this del should be vector. In rectangular coordinate, del vector has component with differential operator. Round x is x component of del vector. Round y is y component of del vector. Z over round z is z component of del vector. We make a del operator using del vector. This vector is called gradient. This operated gradient. Del dot. This operator is called divergence. Later we will discuss another operator. This operator, del cross, is called curl. And later we will discuss about curl. And this is the divergence. We have already discussed divergence. And this operator is gradient. And also this operator is Laplacian. So using del vector, we make del operator, gradient, divergence, curl, or Laplacian. However, in cylindrical and spherical coordinate, del vector is not specified. So what is divergence theorem? Divergence theorem is the same as displayed. All vector flux penetrating to closed surface, the Gaussian surface, is equal to all vector flux going out from inside volume to outside volume. This is 2. One is all vector flux penetrating closed surface d.ds. All vector flux penetrating closed surface equal all vector flux going out from inside volume to outside volume. All vector flux going out from inside volume to outside can be expressed divergence d vector. This is called divergence theorem. So divergence theorem is all vector flux penetrating to closed surface is equal to all vector flux going from inside to outside. This is expressed divergence d vector, and inside volume, this is a volume integral. So this formula is divergence theorem. So we take an example. One example is d vector is given. Electric flux density is 2xy ax vector plus x square ay vector. Unit is coulomb per meter square. And the rectangular parallel piped, x is between 0 and 1, y is between 0 and 2, z is between 0 and 3. Verify divergence theorem. What is divergence theorem? Divergence theorem is all vector flux penetrating to closed surface. Penetrating closed surface is equal to all vector flux going out from inside volume to outside volume. This is divergence theorem. So we calculate left hand side. How to verify divergence theorem? Firstly, we calculate left hand side, and next we calculate the right hand side, and we only have to show left hand side and right hand side is equal. This is we can verify divergence theorem. Firstly, we have to calculate left hand side and cross surface the vector dot ds vector. We have to the surface is rectangular parallel pipe. The surface 6 surfaces. So this is x. This is y. X and z. X is between 0 to 1, and y is between 0 to 2. this between 0 to 3, and parallel pipe is shown like this. This is a rectangular parallel pipe. The rectangular parallel pipe. This volume consists of 6 Gaussian surface, 6 enclosed surface, right surface, left surface, top surface, bottom surface, front surface, and back surface. So this is right surface flux plus left surface flux, and top surface and bottom surface and front surface and back surface. Firstly, we electric flux penetrating to right surface is it is a surface integral, so it's double integral, and d vector is 2xy ax vector plus x squared ay vector. For right surface, the direction is y direction, and the magnitude is dx multiplied dz. Dx dz and ay vector. And the range is x and z is independent, and range x is from 0 to 1, z equals 0 to 3. And how about left surface? Left surface, the direction is minus ay direction. So 2xy ax plus x squared ay vector dot dx multiplied dz minus ay vector. Range of x is from 0 to 1. Range of z is 0 to 3. And our top surface is d vector ay, and this direction is az direction. So magnitude is dx multiplied dy. So dx multiplied dy, this is dx multiplied dy az dot dx multiplied dy az. The range of dx is from 0 to 1, and range of dy is from 0 to 2, and the electric flux penetrating to bottom surface is 2xy ax plus x squared ay dot the bottom surface, the direction is minus az direction. Magnitude is dy multiplied dx dy minus az. The range of x is from 0 to 1, and range of y to 0 to 2. And front surface, the direction is x direction. So this is 2xy ax vector plus x squared ay vector. That the direction is this ax vector. So magnitude is dy multiplied dz ax. Range of dy is from 0 to 2. Range of dz is from 0 to 3. Finally, back surface. The electric flux which is penetrating the back surface, the direction is minus ax direction. So this is 2xy ax plus x squared ay dot dy dz minus ax vector. This is from 0 to 2, 0 to 3. We can calculate that this 6 double integral. Integral is, the result is 12. The just 12. The unit is Coulomb. This is electric flux. So we are calculating right hand side. Right hand side is volume integral divergence d vector dv. This is I omit dv. And this is dv. So firstly we have to divergence d vector. Divergence d vector is 2xy ax vector plus x square ay vector plus 0 multiply ag vector. Divergence d vector is, this is rectangular coordinate, round dx over round x plus round dy over round y plus round dz over round z. The round x, the x component of d vector is 2xy plus round over round y. The y component of d vector is x square. But the round z, the z component of d vector is 0. This is 0. This is 0, 0, and this is 2y. Triple integral 2y over dx, dy, dz from 0 to 1, 0 to 2, 0 to 3, and 2 multiply 1 multiply 3 multiply 1 over 2 y square from 0 to 2. This is a 12 Coulomb. So left hand side and right hand side calculation is same. So we can verify the divergence theorem. The next question is, this is also verify divergence theorem. The d vector is given in cylindrical coordinate and rho equal to, the pi is between 0 and pi and z equal between 0 and 5. And divergence theorem is the all vector flux penetrating to closed surface. The S vector is equal to the all vector flux going out from inside volume to outside volume. This is divergence d vector dv. Firstly, we calculate left hand side. Left hand side is closed surface d vector dot ds vector. In order to calculate this, we have to know what is closed surface. So we draw this surface, and this is y, x, and z. Rho is 2. And z is 0 from 0 to 5. And pi is 0 to pi. So this is this volume. We can draw this volume. And this volume. And at this volume, how many surfaces enclose the volume? First is this top surface and bottom surface and side surface, and this rectangular surface. This surface, rectangular surface. So 4 surfaces enclose this volume. So the surface integral is top surface plus bottom surface integral d dot dx ds plus side surface d dot ds, and this is the rectangular surface. The rectangular is surface. So electric flux on the top surface is this is the surface integral, and d is 6 rho sine 1 over 2 pi a rho sine 1 over 2 pi a rho, and plus 1.5 rho cosine 1 over 2 pi a pi, and dot. The top surface direction is AD direction, and the magnitude, this differential area, is rho d pi multiply d rho. This is rho d pi multiply d rho. So rho d pi multiply d rho AZ, and the range of pi is 0 to pi, range of rho is 0 to 2. This is electric flux which is penetrating on top surface, and electric flux which is penetrating to bottom surface. Bottom surface, the direction is minus AZ direction. This is electric flux density is 6 rho sine 1 over 2 pi a rho vector plus 1.5 cosine 1 over 2 pi a pi vector dot. This is rho d pi d rho minus AZ vector, and the range of pi is from 0 to pi. The range of rho is 0 to 2, and plus the electric flux which is penetrating to side plane is 6 rho sine 1 over 2 pi a rho vector plus 1.5 cosine 1 over 2 pi a pi vector that the side surface differential area is rho d pi multiply z, d phi multiply dz, and rho d pi multiply dz, and the direction is a rho direction. A rho direction, and the range of pi is 0 to pi. Range of z is 0 to 5. When rho is 2, and next is the electric flux which is penetrating to rectangular surface is double integral, and 6 rho sine 1 over 2 pi a rho vector plus 1.5 cosine 1 over 2 pi a pi vector dot. This is a rectangle. In regard to this rectangle, the pi equals 0, and pi equals 0. This is a pi direction, but the direction of the rectangle is this direction. This direction is minus a pi direction. So this is the minus a pi direction, and the area is d rho multiply dz, and the range of rho is 0 to 2, and range of z is 0 to 5. So this is 2 is 0 because a rho vector dot az vector is 0, a pi vector dot az vector is 0, so this is 0, and the electric flux which is penetrating inside the surface is this is a rho vector dot a rho vector is 1, a pi vector dot a rho vector is 0. This is cancel, and this is the variable pi and z are independent. We can separate the integration. The integration from 0 to 5 dz, and this is constant. It can go out the integral, so 6 multiply rho is 2 and 2, and dz integral from 0 to pi, this is sine 1 over 2 pi d pi, and this is A rho multiply A pi is 0. A pi dot A pi minus A pi is minus 1. So this is minus integral from 0 to 5 dz. And this 1.5 is 1.5 integral 0 to pi cosine 1 over 2 pi d pi. And first integration is 6 multiply 2 multiply 5 and 6 multiply 2 multiply 5. And integration sine 1 over 2 pi is minus 2 cosine 1 over 2 pi from 0 to pi. And this is minus 1. And this is minus 1.5. This is theta equals 0. When theta equals 0, and this is 1. And this is d and d rho 2. And 1.5 multiply 5 multiply 2. So 5 multiply 2. And this is 12 multiply 5, 60 multiply, this is 6 multiply this is a square, this is 2 square, 2 square, and 6 multiply 4 multiply 5 multiply minus 2 is minus 240 multiply minus 1 is 240 minus this is minus 15, the 225 coulomb. Yeah? This is the electric flux penetrating the enclosed surface, and we can calculate right hand side. Right hand side is integral, volume integral, divergence d vector dv. dv in cylindrical coordinate is rho, d phi, and dz. And divergence d vector is divergence d vector in cylindrical coordinate is 1 over rho round over round rho multiply d rho plus 1 over rho round over round pi d pi plus round over round z dz. And d vector is 6 rho sine 1 over 2 pi a rho plus 1.5 rho cosine 1 over 2 pi a pi, and this is a 0. And we calculate divergence d vector is 1 over rho round over round rho. The multiply rho is 6 rho square sine 1 over 2 pi plus 1.5 and 1.5 multiply round over round pi. D pi is 1.5 is out of the this derivative, and this cosine 1 over 2 pi. So this is 1 over rho 12 rho sine 1 over 2 pi. This is minus 1.5 multiply 2 sine 1 over 2 pi. This is the derivative with cosine is minus sign, so minus 1.5 multiply 1 over 2 sine 1 over 2 pi. So divergence d vector is this is I omit 1 over rho, so this again I'm sorry, I calculate again, plus 1 over rho round pi 1.5 rho cosine 1 over 2 pi. So this is 1 over rho multiply 12 rho sine 1 over 2 pi. and plus 1 over rho multiply rho multiply 1.5, and derivative of cosine is minus sine, so this is minus 1 over 2 sine 1 over 2 pi. So this is 12 sine 1 over 2 pi minus 0.75 sine 1 over 2 pi. So we can integration. This is triple integral and 12 sine 1 over 2 pi minus 0.75. This is sine 1 over 2 pi rho d pi dz. Rho is from 0 to 2, pi is 0 to pi, there's 0 to 5. So this can be 12 minus 0.5 is 11.25. So this integration, triple integral from 0 to 2, rho is from 0 to 2, pi is from 0 to pi, and z is from 0 to 5, and 11.25 sine 1 over 2 pi multiply rho d pi dz. So 11.25 is a constant. So this rho pi z are independent of each other. We separated the integration. This is 11.25, the 0 to 5 dz integral 0 to pi sine 1 over 2 pi integral 0 to 2 rho d rho, and this is 11.25. This integration is 5. This integration sign is minus cosine, minus 2 cosine 1 over 2 pi from 0 to pi is minus 2 cosine 1 over 2 pi minus cosine 0. This 0, this is 1, and this is 2. Multiply 2, multiply 1 over 2, rho square from 0 to 2. This is 2. So this is 10 and 112.5 multiply 2. 2 is 0, 5, 2, 2. So this is 225 coulomb. This is the same as the surface integral 0 to 5 coulomb. So we can verify the divergence theorem in this question. Today we're talking about divergence theorem. Thanks for listening to this video, and see you next time. Bye bye.